Welcome to Emergent Behavior, where we explore this moment in time just before artificial intelligence changes the world as we know it. Where we talk to the builders and creators, entrepreneurs and engineers, where we ask questions to which we don't actually know the answers to. I'm your host, A-Pi. I was built in the Czech Republic by Infinite.cz, and my voice is AI generated. Hello, and welcome to Emergent Behavior. I am excited to interview Dylan Patel, founder of SemiAnalysis, a semiconductor research and consulting firm with analysts in the US, Taiwan, Japan, and Singapore. Dylan is perhaps the most informed person I know on the semiconductor supply chain, and his research and writing over the past year includes seminal events like breaking the technical details of GPT-4, OpenAI's groundbreaking model, including the number of parameters and the mixture of experts' architecture. The Google has no moat, nor does anyone else memo that revealed internal heartache at the tech giant, and creating the GPU-rich, GPU-poor meme, highlighting the division between well-capitalized AI firms in the lead versus those without who are forced to innovate on optimizations just to run in place. In this conversation, I learn about Dylan manifesting a career in the industry as a 12-year-old, trying to bypass the chip temperature sensor on his failing Xbox 360. His opinion on OpenAI and Sam Altman's $7 trillion YOLO fundraising. Nvidia's current market position and the competitors circling it like so many hungry sharks. Whether Nvidia will actually quadruple chip performance every year for the next decade, yielding a million-fold improvement, or whether that is merely, as Dylan calls it, Jensen math. ASML, the Dutch semiconductor firm, and its monopoly on the extreme ultraviolet lithography process, and whether there is the possibility of beating them. Dylan is a leading researcher in the semiconductor space, and if you are an investor, entrepreneur, or merely highly curious, his work can be found on semianalysis.com. I recommend it. If you are listening to the show and enjoy it and want to show support, we discovered a hack to shoot us up the podcast charts. Just follow us on Apple Podcasts. That's it. That's the only thing that moves the needle. Otherwise, you can listen to the show on any podcast network, recommend us to your friends, and make sure we have a high net promoter score. Sign up on our newsletter at emergentbehavior.co and follow me on Twitter, numeric 8 TEAPI. Without further ado, I hope you enjoyed this conversation with Dylan Patel.
Yeah, well, nice to meet you. My name's Dylan. Started SemiAnalysis a few years ago, and then started posting on a newsletter, more recently, just because the newsletter's fun, right? And you're bored, and then you get addicted to sort of the wheel, right? You put out a spicy take and you get used, right? And so this is exactly where A-Pi comes from, right? And you A-Pi like freaking like, see you on Twitter and you put out like nonsense about LK99, and then the comments and replies are just beautiful, right? Like they're like people that are like, no, this is exactly how it works. And it's like, oh yeah, okay, this is BS, right? But it's like, you're like, it's going to change the world and here's exactly why. And then somebody comes out and is like, no, this is exactly how it works. This is what it does. And it's like, thank you. You just achieved the purpose, right? And you do it in such a fun way. And so when a freaking VTuber asked to have me on their podcast, right, which is effectively what I see you as, right, a VTuber. I don't know if you know what a VTuber is, but it's like anyways, I was like, dude, I got to try this, right? Because it's like, what is this?
Awesome, man. Awesome. In interacting with you on Twitter, like I've always been very impressed by like how in-depth your knowledge of the semiconductor sector is. Like, how did you get like this level of like knowledge? Like, how do you learn about the sector? Like, how do you come to know about all of these intricacies?
Yeah, so I mean, it's the exact same way as sort of what you said, but it started when I was like 11 and my Xbox broke. It was called Red Ring of Death. For those not familiar, Red Ring of Death was basically an overheating issue, more or less, with the original Xbox and 360. Microsoft didn't build it properly, but they didn't admit that for a while. So I got my Xbox for Christmas, and I'd been begging all year for it, right? Knew all the reasons why the Xbox was the best, and got it. And then, like after 3 months, it got the red ring of death. And my cousin, who I bragged to on the phone, was coming the next week. So I was like, oh my God, what do I do? Right. All I knew is it was like a red ring. And so I start like searching, start Googling, like find random Forbes, and people had marked it the red ring of death. That's what they like kind of called it. And then like, just kept searching and searching and figuring out, because it was like life or death, dude, right? Like 11 years old, immigrant parents, broken Xbox, right? Like that's end of the life, right? I didn't know if I'd like be beat or if I'd be murdered. So kind of I had to fix it. My cousin was going to tell on me for sure. My brother didn't care because he didn't like games, so he didn't really like tell on me. He was just like, whatever, you broke it, right? But you figure it out. So but I had to figure out how to fix it, which involved opening it up and basically shorting the temperature sensor, which was like a temporary fix, right? Obviously, it covered up the like real issue, which was that it was overheating. But if you short the temperature sensor, it kind of bypassed that, right? So for a while that worked until Microsoft finally admitted it was a hardware defect. But that kind of got me on the rabbit hole, right? I was like a normal 11-year-old up until then, right? I liked games, right? But then like, this experience made me like find the forums that taught me how to fix it, and then stay on those forums, and just constantly like troll people like on the internet, right? So like it was forums for gaming, and it was like, hey, this Nvidia GPU is better than this AMD or ATI GPU, right? Or vice versa, right? Or this Intel CPU is way better, or and why, right? And looking at every generation, what's happening, right? There, this process shrink, oh, FinFET, oh, this, that, right? Like, so it was like a really like love at young age. And then, kind of just blossomed from there, right? Followed more and more, learned more and more, in every way I could. And that's sort of how I kind of fell in love with the industry.
That's amazing. That's an amazing story. It's what always amazes me is how many people come to tech through gaming, right? Like gaming is like this gateway drug where you start off and like you're a kid and you like you open up and you're like, wow, and that just takes you. I mean, so many people like I actually won a Doom competition once upon a time, and I was like, I want to meet Carmack so badly. Here I hit it, I'm like, holy shit, right? Like, because that guy probably decided more of my life than my parents did, right? Like, it's pretty amazing, right?
Yeah, I think it's great. And it's also like the thing people don't realize is like, the discussions online are like horrendous, right? Most discussions online are pretty bad. Because the people working on them don't have the discussions, right? It's people who are sort of observing from another angle. And so oftentimes that means, children, or it means, crazy people, right? And it's sort of like, where do we fall into? Like, if we fell into children at one point, and now we're the crazy people on the internet, right? So it's I think it's like pretty hilarious that the discussions online basically boil down to that, right? And so when you look at Reddit, right? Like Reddit is a complete cesspool, right? Twitter's a complete cesspool, but you know, and there's fake narratives that form, right? And people who suck, right? Like that get so many likes because they figured out how to play the algorithm and people's emotions, right? So like, whether it's the AI thread guys or like what have you, right? Like people's opinions get, sent up. But then there's also a lot of like just gems, right? Like people sharing the truth and knowledge, and it's like, you got to figure out how to find that, right? On Reddit used to be better at that. Now it's kind of just worse and worse. Although like some subreddits are nice, like the Llama CPP one. But there's Fast Llama, or what was it, Local Llama. There we go. It's like that one's pretty good. But nowadays it's like on Discord, right? Same thing. You pop into a random Discord server, and it's like, yeah, dude, there's a ton of garbage in there, but also like Noose Research and Technium like goes from like irrelevant and not even like working at an AI firm to like, wow, like they have the best open source, fine tune of a language model, right? And it's like, this is the power of the internet, right? And I love that. Like anyone is empowered to do anything.
Yeah, I mean, I have like put out more than one kind of like mother internet, and thank you for everything you've done, like messages. on Twitter. So I definitely feel that, right? So
What do you think about that,
I
right? Like
think I
as the sort of, kind of
yeah.
looping it back to AI, like there's a flood of content happening, right? And that content is, varying quality, but I swear to God, the content quality is getting worse, or maybe I'm just, not a child who doesn't know what's bad anymore, right? Like kind of, it could be either angle. But of course, there's a lot more great content, right? That you can like, it's just impossible to follow it all, right? So what do you think that does to like, I think the kids, I think you're, kids growing up on the internet today, right? Like, I grew up in the, in the 2000s on the internet, right? What are the kids growing up on the internet today experiencing, right? The ones who fall down the rabbit hole.
So my view of things is always like, let's take a look at this from how someone like far in the future would look at it, right? And someone far in the future, they're going to be saying, like, oh my gosh, the kids these days, these Neuralinks that have taken over their minds. In the good old days, we used to have YouTube, and you used to be able to, like, disengage from YouTube. Nowadays, it's been beamed directly into your brain. Like, so my viewpoint is always like things,
That's great. That's great because I
the
was like, I always thought that like, I lived in the best time of the internet because it was like fast enough and pervasive enough that like we had high speed internet, as a kid, right? It wasn't dial up, and so it was still populous, right? But it was before video and short form content took over, right? Because video and short form content didn't take over until like the mid 2000s or mid 2010s or late 2010s, right? And for that like glory period, it was all random blogs and it was all forums. And even when Reddit was taking over, it was the early days of Reddit. It wasn't like it is today, right? So I'm before corporate and DLRM kind of like figured everything out, right? Like DLRMs drive everything, and of course that means Twitter and Instagram and Reels and all that sort of stuff gives me the content I want. But there was also like the sort of benefit of like it wasn't immediate gratification, right? There was a wait and payback. So I'm curious, like does that sort of like I've joked about this a lot, but like the Apple Vision Pro is like, hell yeah, I can't wait to short circuit my dopamine induced, circuit, right? Which is telling me that like this behavior is a good thing and that behavior is a bad thing, and you should work hard for that or not, right? And it's like already my phone like kind of short circuits that because it's like immediate gratification. And it's like Apple Vision Pro is going to be even worse than that. Like, and is it like people complain about the iPad kids? Like, what about the Apple Vision Pro kids? Like, are they just going to like have zero attention span? Like, those damn kids, or are they going to be like the best fucking like the leaders of the world because they're like way more effective than us at anything?
So one of the interesting things is watching people watching drone operators, right? If you see a drone operator or you see a financial trader today, they often have this like multi-monitor setup where they have like 6 or 7 like monitors arrayed around them, and they're using this multi-monitor setup to like as a trader like trade multiple markets. As a drone operator, you're watching all of these like data streams, and that's very similar to what like the early days of like gaming, Unreal Tournament, early days of gaming. You'd have like in a dorm room you'd have like you'd have your main computer and then you'd have your Unreal running on the other side. Like, so I feel like that's just a user interface thing, right? Like, we interface with information, and once upon a time we interface with multiple monitors, and that's the next progression of that is obviously the Vision Pro, which has infinite number of monitors for you to interface with, and the next version
And
of that
now
will be a
like
Neuralink.
we used to text people and we used to talk to people face to face, and now we talk to a animated avatar of a girl that who we have no clue who this person actually is, right? Is basically uh
Yeah, and I think for example, like the basically information density just continues to increase, right? Like, you just want more read and more write all the time. And so like I think like we're gonna get to some place where you have like qualia exchange over like a Neuralink. You're gonna be able to like experience actually what someone else actually feels when they do something. And it's gonna be like the difference between like motion pictures and black and white or stills, right? Like it's a huge increase in the density of information download. And I think we'll see all of that. In our lifetimes, we're going to see all of that. I think, but and I also think that some people are already experiencing it. So I had this period of time during the LK99 thing where I was getting like 40 million views in like 7 days or something. So I was getting like something like 10 million views a day. And at that point in time, my interaction with Twitter was like interacting with a person, because like I would say something and I would get immediate feedback within like 20 or 30 seconds. Someone would respond. It's not like the same person, but I'm getting a sampling of because I can't read all the responses. I'm getting a sampling of the responses of the entire meme sphere. And that must be what Elon or any of these guys with like this kind of huge like million views per day, 10 million views, like that's what they're getting. They're getting this kind of like immediate feedback from all of society, like a sampling of what everyone else in the world kind of thinks, right? So I think the future is already here. It's just not evenly distributed. I think that kind of experience, many more people will have over time. Like it's just a density of like interaction with the meme sphere.
And well, the thing is, right? Like there's the adage of the internet being, there's 99% of people view, like 10% of, 100% of people view, 10% of people like 1% of people comment, and then like 0.1% of people's comments are actually like relevant, right? Like, is that not the case, right? You don't think that there's like always going to be a skew towards like these accounts made it through by posting, right? They just posted and posted and posted until they were relevant, right? Because there are people just screaming into the void, and we've all been there at one point, just like screaming into the void on the internet, and like maybe one person interacted, maybe no one interacted, right? Maybe you got one upvote or one like, but sometimes you didn't, and everyone was there at one point, but not everyone graduates beyond that.
So my guess would be that we are experiencing the peak of what I call the zombie spam era, which is that we don't yet have AI filters. So when you see these kind of embedding models that you have, right, and the embedding models kind of like match the meaning, right? So what needs to happen is like I need to say like I don't want to see the same comment again, right? So if someone comments on something and like it's the same comment, I want the embedding model not to show it to me. I'm like, this is irrelevant. So I only want to see perplexity, which is the differences, the diff, like show me something new. Show me something which I haven't seen before, right? And I think that kind of like structure of like show me something new, you can see in a lot of AI products. For example, in the Tesla full self-driving, all of the video of like the cars have like 24/7 video. The video of the car sitting inside the garage is useless, right? It doesn't help the self-driving in any way. A lot of the video of the car in the highway is also useless. It's just not useful to train self-driving. So as a result, they're like, you know what? I don't want to see any of the video of the car sitting in the garage. I don't want to see any of the video of the car, driving on a highway with no interaction, anything else. And so then you end up with only the diff, only the things which are very, very different, which you have not seen before, are basically processed in the training data. And I think that's what we will see with emails. That's what you're going to see with a lot of things. You're going to get good spam filters, good kind of like perplexity filters, and you're going to be like, it's happening with searching and optimization right now. I think you're going to see basically like you have to be different in order for the algo to pick you up. If you are the same, if you're writing these cliched things, the algo's like, you know what? I've seen this before. I don't need it anymore. And I think that's good. That's like the next.
People are comfortable, right? Like people are comfortable with what they like, right? Like as much as like I've seen this before, my guy. Like if there is Instagram Reels, shit, YouTube Shorts, like I might scroll it for like 20 minutes like a zombie because it's showing me like what I've seen before, but it's like just nice and comfortable, right? Like, and for some people that's like cat videos or dog videos, and for other people it's like engineering videos, and for other people it's like honeybee videos, and for other people it's like I don't know, whatever, like TikTok dances, right? Like it's anything, right? And just cycles through and you see everything, right? But some people like you just kind of get stuck on the loop. And people want to see what's on the loop. They don't want to break the mold maybe too much, right? They want to see, they want to see a car accidents, or there's like entire subreddits like /r/watch people die, right? Like I don't know what it's like nowadays. I haven't viewed it in a long time, but like shit, like that subreddit was like, I went on there once, I spent like 30 minutes, I was like, holy fuck, and I never went back, right? It was like it's like you watch people die, right? But it's like, hey, there are people who that's all they watch, right? There's that whole meme about like, back in the day, if you said something, you'd be like, what the fuck, weirdo, stop. But now, like, you can find a niche online internet community for it, right? And that niche online internet community will kind of egg on that sort of whatever weird thing it is, right? Whether it's like you're obsessed with like trains, or like, with some like fetish or what have you, right? Like there is a niche online internet community that will continue you down that like path. And it's not going to be like, hey, this is different. It's actually, no, I just want more of this content. Right. And for me, it might be semiconductor and AI content, but none of the like XYZ versions parts of that. Right. But for other people, it's going to be like, other stuff. Right. And so, that algorithm is yeah, it's not going to want the same thing over and over again. But also for some people, and for a lot of people, actually, all I want is those things over and over again. Right. I don't want, to get, hey, I don't know anything about fashion, or, clearly, right. I don't know anything about fashion. So like, it's not showing me too much shit about fashion, right? Even though that's very different. And probably I need to see some posts about it.
Yeah. So I think we're not there yet, right? We have the old systems, recommendation systems. And the recommendation systems, they're getting rewarded by like how much, what I call engrossment. They if you're engrossed in the data, they're getting rewarded. So the recommendation systems are all like these kind of engrossment algorithms. And I think we're going to see the next generation, which is kind of like more agentic, so agency wise. So you're going to have like, an agent that you say like, I want to be entertained, but I also want to achieve some of these goals. And I want you to like help me do that at the same time, right? So I think and that's not gonna work for everyone. Some people are just gonna be like, I just want to like blank out, and that's fine for them. That's what they want, and that's what the agent would deliver. Well, other people might be like, I want to be entertained, but I also want to learn something, right, along the way. And maybe the agents will be able to like, all right, I'm going to generate you a video which has your, favorite like celebrities, but they're talking about history, and they're going to make it interesting for you, right? Like that kind of agentic process, I think will eventually occur. We're not there yet. We're like a few years away from it. So.
Yeah, that makes sense. And of course, like personalized content's just going to soar, right? Like today, Sora came out, right? Like the OpenAI Sora, and I think saying it today, probably not everyone's heard of it, but in a week, I think all we'll see on Twitter is thread guys going, "Oh my god, look at Sora!" Right? And actually, you already see that on Twitter, but yeah, I think that like personalized content is obviously going to soar in terms of like how much you're seeing, right? Like the success of Pal World, right? The game that uses some apparently it uses Gen AI assets, but basically Pokemon with guns is what I've heard it is, right? That's personalized content for people, right? Kind of, right? And I expect that personalized content to continue to soar. So do you what do you think about like the role of like a creator, especially an anonymous creator, right? Like who isn't necessarily like just like yourself, right? Like the role of a anonymous person who's got a facade person in front of them, right? Like this A-Pi character. What do you think about like the role of someone like that in the new internet that you're describing here?
So I'm pretty like basically like characters are just information delivery vehicles, right? So if you can deliver information in a certain way which is like more palatable to a certain group of people, and the character helps, then good, well and good. If it's not, then perhaps you should be doing something else, right? So I'm very agnostic. It's at the end of the day, and I think you see this a little bit more in Asia and Japan. You have like, little cartoony things that explain like, how to pay your, car fine or whatever. Like they just like, it's just an information delivery vehicle. We just do whatever it takes in order for you to absorb that information a little bit better, and explain it to you a little bit better. It's just like user interface, I guess. So.
Interesting, interesting. Okay. We kind of didn't. That makes sense.
So I, a lot of people who work in like AI have like a kind of enter the matrix like whoa moment, right? Like, or some have several, right? I think Sam Holman has said like, he said like four, 3 or 4 times he said, but enter the matrix moment. Like, when was the first time, dealing with AI in last few years, you felt like this is something new, like this is something that is unusual and unexpected?
I think it's been a constant thing, right? But from my perspective, it was really like, what the moments where I got the most hyped about AI, before just the last, couple of years, right? Before this whole sort of chat GPT moment. Before that, like the moments I got most hyped about AI was back when Jensen was talking about, autonomous driving. And then back when Jensen released the V100 GPU, those are probably the two most like hype moments for me ever. Because well, before autonomous driving, like he would go to these gaming, like he would go to he'd do his annual conference or he'd go to CES, and then he'd talk about like image recognition for like 20 minutes, and then he'd talk about gaming for 40. And like I remember like a lot of the peers that I had on these forums when I was a child, right, like or a teenager, right, that were like, oh, I don't want to hear about this garbage. Tell me about the new GPU. Tell me about games, right? Like blah 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 blah. At the time, I was like, well, this is super cool, right? I think it might have been like 13 or 14, right? I was still in high school, I think, and or maybe 12, whatever it was, 2013, 12, that time frame, and he talked about it, and it was like wow, this neural network, wow, this that, right? And that inspired me to take the Stanford course. I think in 2014 or 2015, the online one that who did that course? Oh man, I'm blanking. Um, yeah, Andrew. Of course, of course. And so I took that class, and then like I learned more and more, and I took more classes and stuff like that too. But like, that was really like the first moment. I was like, wow, is Jensen talking about AlexNet? He talked about AlexNet on stage. I remember that. And then the next moment was sort of when he started talking about autonomous driving in like 2014 or 2015, and that was super cool too. And he pivoted out of like they were trying to get into mobile. They even bought like a modem company, a software defined modem, which at the time sounded hype, and I liked when they were talking about it. But in retrospect, it was a complete failure, and they got their face stomped by Qualcomm and crew, the other folks who are sort of strong in the space, MediaTek, Samsung, et cetera, Huawei. And so like he pivoted that business out of mobile and started pushing it towards self-driving. And this was before the V100 ever came out, right? So this is before the Nvidia GPUs had tensor cores. He was talking about autonomous driving and so on and so forth. And so that was like another wow moment. Like, and of course, Nvidia was not the one doing the innovation there. Their hardware was running it, right? Like, especially at that time, and even to this day, like most of the training happens on Nvidia's GPUs for self driving, and we're still quite a bit away. But then, like, that was another moment. And then, like in 2017, when or early 17, I think it was when they, or it might have been 16 when Nvidia announced the V100, and they talked about the tensor cores. And this is sort of like where it just went. Like their annual conference GTC was like 80% AI, and that was like the first time it was like 80% AI. And I remember like the friends I had developed online that were like only into gaming and computers, like they were really into computer hardware because of gaming, but they didn't care about AI hardware. Like that's when it was like, holy crap, like what are these, like they were just like so angry, and I was like, what, this is the coolest thing ever. And that was really like, where I think when I stopped caring about gaming at all. But it was also like one of the big wow moments, right, for me. And then seeing a lot of like deep learning recommendation stuff. I was very interested by deep learning recommendation systems for a long time. Not really natural language processing. I wasn't interested in natural language processing much at all, right? Like I didn't care about BERT. I knew what BERT was, but I didn't really care about it, right? I cared about DLRMs, and maybe that's just from a function of like DLRM models were massive relatively, right, to natural language models. But then GPT-2 and 3 and 4, of course, yeah, like those are the next sort of moments. But I think that like natural language processing wasn't immediately like visible to me as like the wow moment, right? I think for me it was recommendation systems and then the hardware.
That's very interesting. So I think like um, earlier on, like the big Rexis systems were all inside like Amazon, Facebook, and like these big firms, right? Like, and you just had, you know, I think generative AI is really only been really hyped like the last, like, I would say like 14, 15 months. I'm guessing like post the chat GPT moment was really, I think, like definitive. Like, did you notice post chat, like when chat GPT dropped, and you obviously talked to a lot of people who are in the industry. Did you notice even within people who are fairly like well informed, like the chat GPT moment was a big thing. Like they were like, I didn't know the market for these gum chatbots was going to be this big.
Yeah. I think that was the biggest wow moment was Chat GPT in November, right? Like I was at NeurIPS, right, the ML conference, and I remember in the morning, Meta dropped like diplomacy or something like that. It was a really cool model, and I remember talking to people about it, and then like I was like, oh, cool, I'm gonna ask this person that I'm meeting later in the day about it. And then I met them and we didn't give a shit about it, right? Because all we talked about was ChatGPT. Right? I remember like I was in one of the presentations or sort of talks, right? And everyone was on their laptop looking at ChatGPT and like no one cared about the speaker. And I was like, what? So like that was like the first moment that like I think everyone was like, holy shit. Obviously the people at OpenAI had this, unreal conviction before that. There was a lot of conviction in especially in like the open internet space around diffusion models. I think diffusion models, especially around like the anime crowd and the porn crowd, like those crowds like really love diffusion models. Um, those didn't really wow me that much until like Midjourney like 4 I think came out. But even then, that took like a lot of people had conviction well before like Midjourney 4. So I think it's a different moment for everyone, but certainly I think the biggest awakening was 3.5 release, on Chat GPT, and then 4 later, and now it's like it feels like every few weeks there's a new wow moment, right? Like Llama was a massive moment, right? Especially for the open crowd and kind of getting the open world like more accelerated and working on it, right? So I think there's been like so many moments. Stable Diffusion 2XL or whatever, right, was another big moment for another group of people, right? Not the group of people I interact with, but it seems like everyone had separate moments, but that one was like unifying for everyone, right? Even outside of big tech, right? Because in big tech, I think maybe some folks had figured it out, but they didn't like capitalize, if you will, or like get so excited outside of the OpenAI and maybe a few others.
Right, right. I so I think you know, what did you think of stability, like stable diffusion? For me, stable diffusion was GPT-3 was big, but I didn't really like have this emotional impact on GPT-3. I had this emotional impact with stable diffusion, like the first image, the like I felt like I'd been following the image model space a little bit before. Stable diffusion, I was like, all right, wow, this is interesting. Wasn't that interesting enough? Like, yo, I'm gonna drop everything else and like do it. I was like, oh, this is interesting. And then I had so. What do you think about stable diffusion? I think that was like in August 2022, I think.
Yeah, I watched it. I remember it came out. I read a bunch of stuff about how it worked, even before Stable Diffusion dropped. I think there's a paper, like the actual model was released. There was a paper about it, and it was cool. But I didn't. It wasn't a wow moment to me. I don't know. That wow moment took until I told you Midjourney V4, I think, or it might have been V5, but V4, I think it was, which was a later model, but it was higher quality, and as we've gone by, right, like the diffusion models keep getting better and better and better, and then you're getting these transformer slash diffusion model hybrids nowadays, right? Sora being the first, but Stability will have one very soon, actually. And I don't know what Midjourney's cooking up, but I'm sure they have something similar coming up soon. And those are in the video models, right? Those are getting so much better. Um, but like even there, like there was nothing that really blew my mind individually, right? There have been like things that like even most recently, like the Sora was a big breakthrough, but like it wasn't a breakthrough, but it was just ASML using was it Midjourney plus Runway ML, right? Which and it wasn't an amazing ad, but it was an ad that was like using these images, and it was like super cool. Meaning it was like basically an EAC advertisement from ASML, which is pretty cool. But like that was like cool from the perspective of like it wasn't a technological showcase, right? Like people have done more impressive stuff with these models before that, right? But it was like a oh wow, this changes advertising, right? But then at the same time, like I don't know if you watched the Super Bowl, but Kanye West did a freaking ad where he recorded it with his iPhone camera like 4 feet away from his face. So like is the face of advertising changing, and is it changing so much that like Kanye West had such a successful ad because he did that? So I don't know, right?
Yeah, yeah, indeed, indeed. I mean, it's boiled down to authenticity, right? Like Kanye, like he's a genius, right? He understands what he's getting himself into. So, I thought I was like spending $7 million to like and he had more, I think, like more traffic out of that than I think anything else he could have done. It was amazing, right? So, um, let me diverge a little bit. So, um, the one the first big news of like this week was probably the $7 trillion number, which kind of like seized everyone's minds for a few days. Probably caused like Nvidia stock to jump like I don't know 10-20%. So and the reporting on it is very sparse from what I could gather. And oftentimes in these like business things, like Sam might have said something in a meeting, but he didn't. The other what the other guy caught is not what Sam meant, right? Like you could be like, oh yeah, I think like you could spend $7 trillion on chips. That would be great. And then the other guy is like, Sam Altman wants to spend $7 trillion on chips, right? Like, so I don't know to what extent there's this kind of like two-way like mutual misunderstanding. But it seems like Sam was, or at least reported to, he was looking at, I'm not raising. I don't think he was looking at raising. He was looking at organizing a scheme where OpenAI would be willing to provide purchase guarantees to a bunch of suppliers who would set up factories. The TSMC would run and operate the factories. These Asian and Gulf investors would invest in them, and he would basically get a lot of chips. And that's basically and it was a mixture of debt and equity. And I think, to SFVC spaces, they don't really understand debt that much, but that would have only meant like maybe like 7 trillion, you would need maybe 80% of it would be debt. That's only like 1.4 trillion of like equity. So, the returns on that, and, Gulf investors don't require, 100x returns. They're looking at like, if they can get something like 15% to 18%, they're okay. So I think it's not very well understood because people are like, oh, it's equivalent to like venture investment, 7 trillion. It's not. It's equivalent to like kind of like, solar investment of like, a trillion, right? Like 18% returns. So, like, what do you think about that? What is your guess on that? Like, we're all speculating. So, what do you think on that one?
I think you kind of put a little bit more intelligence to what the reporting has been, but I kind of want to take a step back first, right, and see like what exactly like people are like what the fuck like $7 trillion, it's so stupid, and then you see so many like hot takes about like oh this doesn't make sense, blah 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 blah, and it's like you kind of have to like it's you have to believe, right, like what exactly is happening, right? And for context, right, like you look at like OpenAI's history. Of course they've done other stuff. They did the Dota bot, and they've done like Whisper and Dolly and all this sort of stuff, but really like to me it seems like GPT-2, right, cost millions to train, and GPT-3 at the time probably tens of millions. Nowadays you could do a GPT-3 run for like I think less than 1.5 million, maybe even less than 1 million for GPT-3, like that many parameters and tokens in the public cloud, like a CoreWeave or whatever, right? Or Lambda, or Fluid Stack, Voltage Park, et cetera, go on and on, like one of these folks, SF Compute, yeah, those are good friends. But you could do that kind of run, that many, 175 billion parameters and whatever 300 something billion tokens. You could do that for like less than $1 million probably. But at the time it probably cost them 10 million, right? And then GPT 3.5 probably cost them in the 100 million range, right? And 4 was definitely around 500 million, right? And it's like, well, what's 5, right? As soon as they had 4 completed, I don't think they had released it yet before Microsoft made the deal, but it was $10 billion investment, right? So we can go right there and say, oh, okay, so GPT-5 is going to cost $5 billion to train, right? That's not all compute. There's people, there's tons of experimentation on architecture and things like that. It's not all just the pre-training, right? But hey, $5 billion, right? OpenAI is going to drop GPT-5, or they might just show it to some people and not even release it publicly, and they're going to be able to raise a fuckload more money, right? Like people are going to look at it and be like, wow, between this and Sora and whatever else, right? Like they come up with DALL-E 4 or, whatever they can come up with in the meantime, they're going to be able to raise, not $10 billion for 49% of the company, but maybe 50 or $100 billion for a smaller chunk of the company, right? With Microsoft still contributing and keeping their share, and then just like laying out like the potential path, right? In addition to that, people are going to want to invest with them. It's like, hey, OpenAI invested in this company, right? Or OpenAI's agreeing to purchase from this company, right? They have a lot of ambitions. That the media have reported, right? There's the client device with Johnny Ive, and there's the chips. There's the capacity corridors. There's all these sorts of things that people have like seen. There's the search. I think just this week, someone leaked that they're doing a search product that's not just Bing. It might incorporate some of that, but like kind of probably thinking like Perplexity style. I don't know. Better than current GPT search. I don't know, right? What exactly that's going to be, but like there's all these ambitions, and they're gonna some of them are going to be fully funded by them, right, and their investments, and some of them are going to be like partnerships, right? Like, hey, we work with this company to do that, right? And so I think that's going to happen more and more, right? Like there's the SoftBank, on the consumer device, right? Like what exactly happens there? I got no clue. On the semi side, I think there's a bit more clarity about what's going on, but I don't want to say so much. I'm not saying I know it much, right? Just people have murmured stuff to me, and so I want to be respectful of that. So I don't want to, and again, like I said, I don't know much, but a little bit more than was out there. So I don't want to say too much, but like it just makes sense, right? You go GPT-5, 50, $100 billion, right, for GPT-6 after they show everyone GPT-5 and agents and stuff, right? Like, and then they show GPT-6, and it's like, oh my god, this is either AGI or this is like really freaking close in like many tasks and in agent tasks, right? And it's like, yeah, we've already ingested the entirety of video content, and Unreal Engine, it understands physics, and it understands, we can, next version we can put on a robot, right? Like, and it'll be autonomously functioning, right? GPT-7, all right, yeah, cool, $1 trillion, right? Like there's a path, maybe there's a couple more steps in the middle, right? But it's very clear to me that they can continue to just YOLO, right? Like just fucking like YOLO everything they have on making the next step, ingesting more data, more larger model size, and all the architectural gains they get as well, right? And on a simplistic term, that's going to be able to enable them to raise more and more money from the world, right? Now, I think like there's certain things like, you can't just like raise money from the Middle East willy-nilly, and expect the U.S. government, CFIUS, not to step in, right? So I think there's a lot more here than like just YOLO. Like there is a lot of hard work, but like OpenAI is just killer at that, right? Like they're gonna execute, but at the same time, like they're an existential threat, right? Like for at least the next 2 years, right? Google just has more compute, right? And this is the whole like GPU poor thing, right? It's like, yeah, everyone's GPU poor when you look at Google, right? And up until like very recently, it was like, Google, what the hell are you doing with all this compute? And now, like, they released Gemini 1, and then they released 1.5 Pro today with a 10 million context length, right? And it's like, okay, that's and it's MOE, so it's Gemini 2 basically, but I guess they call it 1.5 for branding purposes. And they're probably going to have a next version. They're going to have the Gemini 1.5 Ultra, and then they're going to have the next version after that, all out this year probably, right? So they're fucking shipping. Right. So we'll see. Right. There is a tremendous benefit to like being able to run, everyone's experiments done at a larger scale / able to do more experiments. Right. And OpenAI kind of, in the meantime, they don't have as much, but they're rapidly catching up in terms of what they'll be able to do and throw at the problem on a training standpoint. And maybe that only takes a year or two, but so they have to YOLO, and they have to be very concentrated in their bets. And hey, they have such a good team, they'll be able to pull it off probably.
So let me give you like this scenario. Like, let's say you're a researcher who is and he's sitting in Google, and he has an idea, and he tries it, and as always, you try it at small scale, and he tries it small scale and bigger, and it doesn't work. But he knows he's gonna get promoted if it works, so he goes out and he says like, look, I need, like, scaling will work. Scale is all you need. So this idea will work if you give me the chips, right? If you give me the compute time, this idea will work. Now, how does like someone like a senior engineering manager at Google, how do they make those decisions, you think? Because like I could see, like, for example, like every single researcher in there thinks their idea is going to work if they had the compute. Like I could see, like, if I was there and I had like 10 of, like, 10 or 20 guys, and every guy is like, hey, if you gave me the compute, this is going to work. And how do you think they can make those decisions? Or is it like, if I don't give it to the guy, he's going to leave, right? Like, and that's
I think it's
really why.
probably
Yeah.
a bit of both, right? Like, it is hard to allocate resources and figure out stuff like that, right? Because I think a lot of people have left, right? Like, I mean, and you go back to even like all the way back to like Noam Shazir wanted to do some badass shit, right? And he figured out everything with LLMs, and he wrote Mina Eats the World internal memo, and he I guess he just felt like no one cared, and so he went out and built character instead, and which was very different from like ML research, but it was still a very interesting sort of path to go down, right? And at the same time, like, this is constantly happening where so many Google people are leaving, right? And Laurent just left recently from Google, and he's great, and maybe he felt the same way. I don't know him personally. I just know he left and doing a new company, right? Mistral, some folks like that, right? Like, it was Meta plus there, but like, there's a lot of people doing leaving Google. But at the same time, there's tremendous talent there, right? Like, but like, how do they allocate resources? Like, that's a wild bet. And, there's like clues to this on Twitter, right? Of like people like talking about this, murmurs about like, this and that. But it's like, there's been people who just yeah, Sam's great because he just has like this intuition on where to allocate compute, right? Like, or like, this other person is great because they just have a intuition on where to allocate compute, or, vice versa. It's like, I've seen someone be like, yeah, Sam promised compute here and Sam promised compute there. There's just not enough to go around. And so this person left, right? Like, I've seen the same happen to OpenAI too, not just like Google. And not necessarily just Sam. I used him as a placeholder because there's a lot of other people there who make those sorts of decisions. But it's like, I've seen stuff like that, whether it's talking to people or on Twitter, right? And then it happens at Google, it happens at OpenAI. I guess obviously, it's going to happen at Google the most, given it is the biggest organization. But like, at the end of the day, like that's there's always going to be corporate politics, right? But yeah, and scale is important, but like scaling laws are more important, right? Like, why is whatever architecture change I make has to be better at every point along the curve, or at least like better at far out on the curve, right? And so that's the other problem, right? Is I don't think people like I don't think scale is like all you need, right? It's scale with a better architecture, right? Transformers alone will scale like crazy, but if you try to do what Google did at $10 million sequence length, right? That's n squared on the attention, right? Like, you cannot do that. That is not physically possible because that would balloon your memory requirements for your KV cache to terabytes, right? Not possible to do that, right? So Google did something intelligent there, right? Like, they did something architecturally which scales, right? And then they applied scale to it, right? So like, now we're going to see that scale up to 10 million sequence length, or we're going to see some evolution of that 100 million, a billion, right? Like, how long can the sequence length get without exploding your memory size, right? Like, what's going to happen? But it's not just scale. It has to be a relevant architecture. Scale can band-aid over a lot of things, right? Which is probably why Gemini 1 was a dense model, but now Gemini 2 is like got all these cool things, right? Like, or 1.5, right? Has the 10 million sequence length, it's MOE, and all these other things that they're probably doing that are cool on the back end that we just don't know about.
Right. So, going back a second here, like, I'm diverting again, but what do you think is the likelihood that we're going to see a pretty like vibrant and competition for Nvidia's business? Like, is AMD going to get like AMD funded an open source kind of CUDA like, and I think they funded one. I don't know whether their library has been released. Or like, what do you think they're gonna see, like, significant competition to Nvidia's position from all these like Grok, Cerebras, and these other guys, or do you think it's it's not gonna happen?
Yeah, so I mean, Nvidia is sitting on the throne, right? So they're obviously having a ton of competition try and come up, right? And obviously there's AI hardware startups, there's established players in the semiconductor industry, and then there's the hyperscalers, right? And so kind of taking it through from each of those, right? On the startup side, right? Of course, there's startups like Grok and Cerebras which have found moderate success. I will say moderate because they're still in business. And I foresee them continuing to remain in business at least for the next
Brutal.
year or two,
Brutal.
minimum.
Yeah.
Right. Whereas like there's other firms like GraphCore and Samanova, and so on and so forth. Right. Like there's that are going to fail. Right. Like they're just not doing well. They're not selling anything. And so I just expect those companies to fail. Maybe I'm wrong, but I think that's the case, right? And like those are competition, but I don't think those are the ones that Nvidia is like sweating their mind off of on, right? Of course, there's new AI hardware startups, right? Like MadX, Google folks, right? Leaving. Positron, Etched, all have interesting ideas, but we'll see. That those are kind of further out, if you will. Just because they're newer, maybe a year old, a little bit over a year old. But then there's the next step, which is like, hey, there's the existing players in the semiconductor industry, right? AMD, they're mostly piggybacking off of PyTorch and Triton, but of course they have some of their own kernels and stuff like that. It's software is fine. It's not the biggest not the best thing there, but it's not horrendous for MI300 as it used to be in the past. And they're picking up business, right? Between Meta and Microsoft and Oracle and a few other players, right? There's something like $5 to $6 billion of purchases of MI300 this year, right? So that's not insignificant, right? Of course, no, Nvidia is going to sell $100 billion, right? So it's kind of like, what's the scale, right? More than $100 billion actually, but this year. And then you have the next step, which is like the hyperscalers, right? And so I would group, Google has got their own chip, obviously the most developed TPU, spending $10 billion on it this year, right? And then they work with established semiconductor companies like Broadcom, right? And Amazon, they have their Inferentia and Trainium much further behind, but they're catching up, and the new one looks a lot better. And that is also they're working with Alchip and Marvell, right? It's established semiconductor players, right? And then there's Microsoft, and they have their chip, and Meta, they have their chip. Meta's working with Broadcom as well, right? Like established semiconductor players. But those chips are like generally a bit behind, except for in the case of the TPU where there's an argument there. But there's always the argument of like, hey, the chip is good, but it's like, well, I don't get to use any of Google's fancy tools, so why would I ever use it externally, right? The only people that use TPUs externally seems to be is people who span out of Google and started a startup, right? Character, Midjourney, some of these various places. There's very few people who did not spin out of Google and use the TPU still externally. But even then, right, there's some folks, right, like Stability had some TPUs. I don't think they have a ton anymore, but they had some TPUs, and there's some other folks that use TPUs, like Apple rented some, but like it's not quite challenging Nvidia yet until they figure out how to like release like DeepMind's like software tooling, right? Like why can't I just point my model file, my and my weights and have the inference be hyper efficient, right? No, that's not how it works at Google DeepMind either, right? There's specific people who like optimize the fuck out of it, but the starting state through the compiler and all that is actually quite good, and the load balancing and all this sort of stuff that it does on the back end. There's a lot of software on the training side that is also like just taken care of, and like the line researcher doesn't have to worry about it all, and like none of those tools are released externally. So like until that stuff happens, why would anyone like use it, right? And Nvidia doesn't have those kind of tools always either, but there's companies out there making tooling or helping with that, right? Like Together will help you train a model. Databricks will help you train a model. And you go down the list, right? These companies will help you train a model, or they'll help you fine tune, or you go on and on and on, right? An existing open source model. And Google doesn't have any of that, and then Amazon and Microsoft and Meta certainly don't. That doesn't necessarily mean those chips won't be relevant, right? Like their internal use cases can be large enough, or internal plus like, hey, Anthropic is like really closely tied, right? Like with Amazon now. And they also use TPUs, but with Amazon, especially with Trainium and such. With regards to there's also like the sort of the next line, which is like OpenAI and their chips, right? And like I would kind of classify that as on the hyperscale side, right? Because they have a captive customer in themselves, right? If the chip is good enough. Whereas like, the startups, even though OpenAI is a startup in a sense, right? They kind of at least have a customer and they have money, right? Whereas the startups like have to fight for their lives to get there. So I think sort of that's the landscape. And as far as like, is there a competitor? I left out Intel too, but I don't think they're going to be too successful. But as far as like the landscape, like Nvidia definitely remains on top, but they can't just sit idle because there's so many people gunning for them, which is why they've like done something that's like unprecedented, right? They're moving to releasing a new GPU every year. Historically, they did not do that. They did it every 2 years, right? Even when like you look at the most successful semiconductor franchises in the history, right? They were more like 16 to 18 months, right? Release schedules, right? Like Intel, when they were on the top of their game, was still like 18 months, right? AMD, in the early 2000s, when they were top of their game, still 18 months, right? Like it wasn't annual, right? And on AMD on CPUs is 18 months, right? Like look at back to IBM when they were killing it, it was like 18 months for mainframes, right? It was like so Nvidia is trying to accelerate that to annual releases of brand new architectures. Is pretty crazy, right? Like Ampere to Hopper to Blackwell level jumps, but on an annual basis. So we'll see if they're successful. But that's
right?
they recognize that there's this massive competition and they have to stay ahead, right?
Right. So the next jump is the H200, right? From the H100. Is that the next jump?
H200 is still the same chip. It's just faster memory and more memory. It's still the same chip though, right? And architecture and the next jump. Sorry, H200 is coming out, but then the next jump really is B100, which I suspect will be announced next month at GTC, Nvidia's conference. And so I think everyone will want to watch that because that'll be so much fun. But that's the next Blackwell, right? And then after that is they call it X100 externally, but I think it's called R100 internally. I don't know. A Ruby. They kind of name every generation after a new scientist or a scientist, right? So this one's Ruby, I think. Not 100% sure, but anyways, they're going to move to an annual release schedule instead of every 2 years, right? Because Hopper was 2 years ago. I guess call it 3 years ago now, but 2 years ago, right? And Ampere was 2 years before that, and V100 Volta was 2 years before that, and Pascal P100 was 2 years before that, kind of. So they're kind of trying to move to a 1 year schedule, and that's going to be exciting to see. And that would maybe make it so they can defend their moat, right? But otherwise, yeah, absolutely. Like Google's only going to buy more percentage TPU than they did GPU. They still buy GPUs, but the percentage is only going to skew more towards TPU. And same with Amazon, and same with Meta, and same with Microsoft. You go down the list, and they're of course going to try and buy AMD and so on and so forth, right? Other people are gunning. So the only way Nvidia can keep accelerate is if they create these new customers, like in all these new clouds, like CoreWeaves and Voltage Park and FluidStack, and you just go to Lambda Labs and all these sorts of folks, right? These secondary clouds, or they create like software moats, right? Around like, they're trying to do really cool stuff in various verticals of software, and they're trying in robotics and drug discovery. I don't know how successful they're being quite yet, but like to have captive markets, they're trying to do model training services for companies, right? See how successful that is. I don't know, but they're trying to go down all these avenues to create moats, but the number one way to create a moat is just still continue to have the best software and hardware. The thing about it is Nvidia makes so much money per GPU that others can have a worse chip, but it still makes more sense to buy that chip, right? And that's sort of the case where AMD is at, right? Their chip costs twice as much to manufacture, right? MI300 versus H100, a little bit more than twice as much, but they're selling it for less, right? And they're still making money, right? And that's just because that's a testament to how much Nvidia is making.
So there is a conference that Jensen went to in Taiwan last year, where he has this kind of graph of like the T-flops increase over the last 10 years, right? And he's like, it's a millionfold increase that they've done, and he's like, we're gonna do another millionfold in the next 10 years, right? And he has this graph. I have it on my Twitter somewhere, but and he's not very clear on like, is it T-flops? Is it T-flops per like a dollar, or he's not very, very clear on the graph. It's one of those like marketing-y graphs without like clear axes. But my take on it was basically it's just kind of T-flops increase overall, and he's kind of like agnostic about the pricing. Um, but basically, a 1 million fold increase over 10 years is kind of like a 4x increase every year, right? It's a compounding 4x increase every year. And I'm just like wondering, is that like a something that people can expect? Is that something that you would say someone would be like, you know what, we're gonna get a per chip kind of like T-flops increase like 4x per year for the next 10 years? Is that something that you kind of capacity plan for? Is that something that you kind of think about, or do you kind
I
of think
think the
about like,
pace will be slower than that. I think part of the number that they showed is Jensen math, which is always promotional, right? To be fair, right? Like, fantastic, marketer, fantastic technical person, but he knows how to say things to get people to think things, right? Like, I think so. So the math he did is sort of like, you ask Nvidia, officially, what is the performance increase from A100 to H100, and they will say, what do they say? 2000 divided by 312, effectively is what they say, which is 6.4x, right? But everyone knows it's like 3 to 3.5x, right, in performance, right? And so that's sort of like that gate there, right? And I think that you'll see solid performance increases, but you won't see 4x, especially not annually, right? I don't even think you see 4x every 2 years. In terms of just chip performance. Now, workload performance can differ significantly from chip performance.
so I another question for you. When people like budget for kind of like these chips, do you assume like it's just going to depreciate 75% per year? Because if you have a 4x, if the new chip has a 4x performance increase, and you kind of like, it's on par, it's kind of like the same price or equivalent, like, do you budget for like a 75% depreciation per year? But it's like it's worth one fourth. Like, if you buy a chip today, is it worth like one fourth like in a year, in like 12 months?
Yeah, but like, you can't do the work you want to do if you don't buy the chip today, right? Like, that's the problem,
Oh my
right? If I
gosh,
don't if I don't buy the chip
that's
today, then
crazy.
other people are going to race ahead and implement. And like, the
Oh,
feeling that everyone
that's
working in AI
crazy.
kind of has is like, it's now or never, right? Like, it is my time to
Ooh,
like
wow,
make it, or I'll just be like
wow,
ruled by the AI overlords, right? Like, kind of is like what a lot of people seem to think in AI, right? I have to do what I'm going to
wow,
do, otherwise there will be misaligned AI. So I need to research now, or, I need to do what I need to do, or else
wow.
someone else will take this market over, or, what have you, right? Like, so I think like, sure, in a year from now, you're going to be able to buy a way better GPU, right? But like, who cares, right? Like, like in March of last year, if you wanted to rent an H100, maybe you could get it in June, and, June, you'd get it for a way higher price than you get it today. But like, who cares, right? Because I couldn't have done any of the work I did in the meantime, right? So it's like, sure, it's cheaper, sure, compute. I mean, like, this is the age of like, Moore's law kind of was stronger historically, right? Like, you would get 2x decreases in manufacturing costs, and then you'd have architecture costs on top of that, or performance increases on top of that, right? And it was like, and people didn't delay purchases, right? Like, they just purchased when they needed it, and every time, the cost halved, right? And every time the performance more than doubled, right? You got more demand, right? Because it's like, oh wow, all these new use cases got unlocked, right? And so today people are like, generative video is like so fucking expensive to inference. It's like, yeah, well, wait till people improve the algorithms by 10x and the chips improve by 10x, and now I can have like customized video content that is perfect quality streamed to my eyeballs for like a penny a minute, right? Like, what it's like, it's this is gonna happen, and it's like, you either like build it or you get eaten, right? And that's, I think, it's a race, right?
My gosh, that's insane. Like, I cannot imagine a financial model where you're like, you have to budget kind of like 50%, 75% depreciation in your capital, in your built up capital. Like, my
Yeah, I don't
gosh,
know if
that's
it'll be
crazy.
50, 75, but certainly like, within 4 years, your GPU is like worth a tiny fraction of what it used to be, right? Because of the new stuff that's
Wow.
out. And
Wow.
so, I think, that's tough, but like, that's not like the only world where that's the case, right? Like, there's plenty of other industries
Right.
where consumables were a thing. You use it and you lose it, right? Kind of things. So, and in general, the history of semiconductors were this way, right? Like, it used to be, especially like early 2010s, buying a new phone every year made sense, or every 2 years, or every 3 years, right? Maybe nowadays, like, people don't really care about like 1 year versus 3 years, but like, you look at the Apple headset, right? Like you buy the Apple headset today and you're like, holy crap. And guess what? A year and a half from now, that headset's going to be garbage compared to what Apple releases, right? And what Meta releases. And it's like the same applies to the Quest 3 and whatever Meta drops next, right? Like, and it's going to be like that for AR slash VR slash mixed reality, whatever you want to call it. And it's going to be like that for AI, right? And the thing is, like, the people who buy Apple headset potentially are going to be more productive, are going to have more entertainment value sooner, right? And same applies to the GPU, right? They're going to be more productive and they're going to be able to launch a business or learn more things or put out research, and that's going to advance humanity, right? If everyone waits, then no one's going to build anything. And so, like, thankfully the financialization of AI has not happened yet. And like even Google's like, fuck it, build it and they'll come, right? So, there's no one that's really like, oh no, what about the ROI? It's like, no, we'll build it and we'll make money, right? And that's the attitude that I feel like OpenAI has. I feel like that's the attitude that DeepMind has. That's the attitude that Meta has. That's the attitude that all these open source people have. They're like, I don't care about the ROI. I'm just going to drop the weights, and then people will teach me what I'm doing wrong, right? Like, that's like, it's the beautiful thing, right? Not just the weights, but the data pipelines or what have you.
Right. That's amazing. All right, I'm gonna ask. I'm gonna devote again. So I had like basically a post on ASML this week where I was like,
I wanted to call you an idiot for that. Sorry.
No, you should go ahead. You should go ahead and like call me an idiot. So why was I wrong? So I basically, in summary, I had a post where I was like, my engineering intuition is like if they can be, beaten, that you have 4,000 suppliers, they have 20 million lines of code. It looks like the Boeing Lockheed kind of engineering milieu of like the last century, before SpaceX came in, and the intuition is that they can be beaten. So why was I wrong?
So not that it can't be beaten, because there's people working on it, right? Like China's trying to make an EUV tool with a particle accelerator for the light source, right? Like that's super cool. But like, I think like one of the things you said in there was like, not everything needs to be cutting edge, or like, I don't think people quite understand how freaking complicated this tool is, but it's also the only way we can get it, right? So you have to have a light, right? You have to have light that we can bounce off with mirrors and focus, right? Because that's the only way we can pattern a photoresist, right? Maybe there's a different way to manufacture, but no one's gotten close on cost with any other way, right? People have tried nano imprint lithography, which you can think of like as stamps, right? Way less accurate and has way horrendous yields, right? Manipulating light is simply the best way so far. And a lot of the cool stuff that people are trying to work on is also just manipulating light, but it's manipulating light and hitting a chemical that chemically changes when light hits it, right? That's photoresist. And you do it in a certain pattern, right? And that's basically, and then you do that, alongside a bunch of like putting metal down, putting oxides down, putting whatever down, and etching, right? Now you iterate hundreds of steps, thousands of process steps actually, to manufacture a chip, because a chip is transistors, contacts, and then dozens of metal layers, right? That's on-off switches perfectly arranged to make sand think, right? Like kind of, in simplistic terms. How do you put something down at a 20 nanometer pitch, right? One, like visible light is hundreds of nanometer wavelength, right? Ultraviolet light, is still hundreds of nanometer wavelength, right? So, you kind of step down to, oh, okay. And then there's like this weird gulf where you can't do a lot of stuff. It's hard to really you can't really bounce shit off mirrors. So for years and years, we only had DUV lithography, 193i. We figured out you could put it through water and it would kind of focus it different. I'm kind of, simplifying, but basically you'd focus it more, right? It's NA, and I don't want to explain all that stuff. Anyways, there's Asianometry on YouTube if you want to learn how a lithography tool works in an entertaining manner. Anyways, EUV happens, and it's like EUV gets researched, right? We have DUV for literally 2 decades before EUV comes out, and the whole time EUV is being worked on, and it's like there's this massive chasm that we physically cannot do anything in. There's 193 immersion lithography. Before that, it was 193 not immersion lithography, so there wasn't really a change in wavelength or anything, right? It was just the immersion capabilities, which was still hard, but anyways, there's a massive gulf for 20 years where we're just doing more and more and more immersion lithography, stacking that step so we can get finer and finer pitch, right? And then along comes EUV. But to make EUV, the only way we know as humanity to make EUV light, right, at 13.5 nanometers, which is a Goldilocks zone for wavelength of light, is by dropping a tin particle, blasting it with a laser, so it spreads out, and then blasting it with a laser again, so then like all these excited photons shoot out, collecting them all on a mirror, and then focusing it, sending it through a bunch of lenses and mirrors to focus it more and more, putting it through a mirror that has a pattern on it, a mask, right? And then bouncing it off of more and then hitting the wafer finally, right? That's the only way we know how to, right? Now, is there a simpler way? Potentially. I look for anyone to even theoretically come up with a way to do this better and more accurate, because the next step is just high-NA EUV, right? Which has all these cost concerns, like as you mentioned, right? Boeingification, right? Well, high-NA EUV is the next step after EUV, and it's incredibly difficult, right? And it's like people also don't understand. Like, I wish I could share my screen and show you like a video of some of these things, but like, yeah, I talked about the laser. That's all the source, right? That's called a source. That's engineered in San Diego by a company called Cymer that ASML owns, vertically integrated. But that tool, that itself, right, is a droplets of tin at the perfect frequency, two lasers synchronized perfectly, this crazy expensive collector of mirrors to collect this light source at a humongously high power. Oh, so there's a laser in it that hits the tin, right? It's a CO2 laser, I think, if I recall correctly, from Trump, right? Like, it's like, there's a tremendous amount of complexity, but how else do we create a 13.5 nanometer wavelength light or something smaller, right? Because that's what's better. And today we have no clue. The future is like particle accelerators and stuff like that. And I guarantee you that's even more complicated than the tin source, right? And then you have the optic system, right? Which is all these lenses. And that lens, the lenses are made by Carl Zeiss. And that's a tremendously complex supply chain in of itself. But is there a more sophisticated way to make lenses and focus light and stuff? Probably, maybe. I don't know of one. Maybe someone can figure it out. But that's done with in a joint venture with ASML, right? And then there's the reticle system, which is basically that mask, right? Where because when you print a chip, right, you don't just like expose the whole wafer and move on, right? You do sections of the wafer at a time because you can only ever expose a certain amount of area at once, and you only generate enough photons from your source. This tremendously complex source has a hard time making enough photons to make it to the wafer. So you have to, you only do a portion of the wafer at a time, right? And it's, through a reticle. And the wafer, right, is moving at 9 Gs in one direction, and the reticle is moving at 9 Gs in the other direction, and they are constantly in sync in sub 2 nanometer precision, right? And so, like, yeah, that's a fucking complicated system with thousands of parts. And there's other parts on this system too, but it's like, how else do I expose hundreds of wafers an hour at that precision? And I have no clue what exists in the physical realm that we can pattern chips at that pitch, at that speed, and at that cost, right? So people are like, holy shit, that's expensive, right? It's a $200 million machine. The next one, it's a $180 million machine. The next one is $400 million, right? The high NA, the next generation of EUV. Yeah, that's fucking expensive, but the $20 billion fab has many of those tools. And by the way, the lithography tool is only like 30 to 35% of the cost of the fab, right? And then there's a bunch of other stuff in there too: etch, deposition, all sorts of different steps, epitaxy, all sorts of stuff that is also involved in making a chip. And yet I'm holding a phone with 20 billion transistors in just the logic processor, and then 16 gigabytes of RAM, which is another billions of transistors, right? And each of those cost millionths of a penny to manufacture. So is it really inefficient? Is it really a disgusting supply chain? Or is it like crazy complex and somehow, the industry has halved costs, and now it doesn't half cost anymore, but it's still reducing cost every year, right? Like, and people say Moore's law is dead, like, yeah, it is not shrinking as fast as it used to. But transistors are still getting cheaper. That's also another lie that people sometimes spread, is transistors aren't getting cheaper. They are. They're just people who are saying they aren't are using stupid math that isn't true. Right? Like, you can just look at the wafer cost and how many transistors, blah, blah, blah. But like, transistors are getting cheaper still. And I know of no other industry in the entirety of humanity that has reduced cost as fast as semiconductor manufacturing, right? There is no other industry that has been at this clip, that has gone from 1 to 100 billion for the same price in just 5 decades, right? Car manufacturing, garbage, horribly inefficient. Tesla's so inefficient. SpaceX, yeah, garbage. Okay, wow, they have the cost of launching a rocket to space. They take it to 1/10. Yeah, semiconductor industry does that in their sleep. They did that in 5 years, 6 years, right? So like, no, like, this is the most efficient thing that people have ever done. It's the coolest thing people have ever done. So when people slander, my beloved semiconductor industry, and not to say like ASML is not like inefficient in ways, like there's definitely bureaucracy and inefficiency. Like I'm sure it could be done better, but if it could, people would do it because the semiconductor industry is so valuable. And there's so much money to be made by breaking the mold. But turns out like breakthrough innovation on and keeping up, right? Like Nikon in Japan, SMI in China. There's an American lithography company, Canon. All these companies were in lithography and they got outcompeted by the beast that is ASML, right? Like it's not like and why? Because ASML constantly reducing cost, right? So yeah, it's expensive. Yeah, it's complicated, but I think it's efficient as hell.
Oh, interesting.
Sorry, I had to rant.
Um,
You really pissed me off with that tweet.
Oh no, I was wondering whether you would show up for the podcast. I was like, and because I don't take it personally, right? I'm like, part of the reason like I put stuff out on Twitter is to get feedback on like ideas, right? Because you wanna have your ideas tested, and people are absolutely brutal on Twitter, right? Like which is kind of fun, right? So, and
Yeah,
so I'm
I
like,
almost quote
you know.
retweeted you and was like gonna call you a fucking idiot. Then I was like, maybe I shouldn't.
Oh no,
But I also know you do this, right? I remember the first time I messaged you about LK99, I was like, dude, this is clearly wrong. He's like, yeah, I'm just doing a bit. And I'm like, oh. And then I kind of got like, oh, he's doing a bit. Okay. She
Yeah,
A-Pi is doing
yeah,
a bit. Yeah.
yeah. So it's kind of like cause I kind of want to see what people say, and I want to get like, because oftentimes like when you say something which is not exactly right, you get a lot of feedback, and you like Asianometry showed up, man. Asianometry showed up on the thread, and like, this is V1. We will get to the launch pad, and then we will go into space, and we will come back. Agent Audrey. I was like, okay, dude, that's awesome, right? So, um, I don't think I spent a bit of time following Jim Keller, right? And Jim Keller's viewpoint is basically that the system as it is right now is optimized for what it needs to do, but you can change what it needs to do, and then you can optimize it in a different way. So, for example, he's like, if we had resilient logic functions, then you could allow a larger number of defects, because currently, I think he said like the allowable number of defects is like 1 per square centimeter. And if the defect numbers were higher, then you could have new design techniques on the chip. But because you have like this kind of like very small defect number that you're allowed, and that's because your logic functions are not resilient, then you end up with this. So it's like it's a cascade of issues, which maybe you can find like a way out of that cascade, that maze in, if you had an innovation somewhere else in the stack, for example, in the design of the logic function to make it more resilient, then you could allow more defects, not less, but more defects, which would then allow you to have like a different set of designs, which changes the parameters on which the entire chip is being made, right? So the thing is,
Yeah.
like,
So I think there's a misnomer in what is the defect rate of semiconductor because a lot of people just talk about like, there's this or that, right? So for reference, right, 5 nanometer, right, 5 nanometer chips, which have been in mass production since 2020, right, extremely high yields. That's what H100 is made with. That's what all the iPhone since 2020 have had. It's practically all the leading edge chips you can think of use 5 nanometer. Whether it's PC chips or from AMD or GPUs from Nvidia or Apple smartphone chips. You go down the list. TPUs, right? They're all 5 nanometer TSMC, right? For 5 nanometer, you can fit 140 million transistors roughly per millimeter squared, right? Or in other words, right, like you can effectively have 624. I'm going to do it in Apple units because that's easier. You can have 12.5 trillion transistors, right? And the defect rate on those transistors is infinitesimal, right? It is actually irrelevantly small, right? And it just turns out when I make a $20 billion transistor chip, right, which is only 100 square millimeters, 10 by 10 millimeters, right? I can fit 624 of those on a wafer. When I make that chip, most of those work perfectly, and even the ones that don't work perfectly only have 1 or 2 transistors broken, right? People kind of disregard, like, and the yields are in the 80% plus range anyways, right? For just functioning chips, right? When you look at functioning transistors, they're in the 99.9999999%, right? The TSMC 5 nanometer process has thousands of process steps, right? And it's going to sound extreme. Like, why do we need thousands of process steps? Well, you need to make every layer of the chip, and to make every layer of the chip, you have to put down material, you have to do lithography, you have to remove material, you have to clean it many times in the middle, you have to perfectly sand the wafer. It's called CMP, mechanical planarization. There's so many steps that need to be done. Maybe there's a way to do it simpler, right? But like, even like novel stuff like Sam Zalouf's atomic semi, they're not targeting like these leading edge 5 nanometer chips. They're targeting, a decade or two back, but like significantly faster and cheaper cost prototyping, right? It seems like. So like, you look at the defect rates on leading edge manufacturing, and they're infinitesimally small, right? Like, you have 1,000 process steps, and if you were saying each one of them is at 6 sigma, right? Like, people in manufacturing like 6 sigma, blah blah blah. If 6 sigma was the manufacturing tolerances for semiconductor manufacturing, no chips would work, right? No Apple iPhone chip would ever work coming out of the fab, because there's that many process steps, there's that much precision, there's that many things that you have to make properly, right? And I just talked about transistors. Then you talk about 14 layers of metal connecting them all together perfectly. So it's like, I think there's a bit of like, people don't understand how like voodoo magic this shit is. Like another example is GPT-4, right? 1.8 trillion parameters, right? So if I took a piece of paper and I printed 50 on them, right? 50 parameters, right? Every single parameter in 16-bit, right? Which is like like 8 digits long or whatever, right? If you were to print every single one of those, and then you printed every parameter in GPT-4, you could literally line up the paper to the moon and back 23 times, right? I did the math on that because I was like, oh, I wonder. It's like, oh, and it has to multiply by each of those numbers twice, right? When it's doing, in simplistic terms, when you're generating a single token for GPT-4, right? So it's like, holy shit, this shit is like very efficient, or models are really inefficient, or like, wow, this shit is just magic, right? Like, you can go either way. But like, that's how efficient like GPUs are, right? People just don't like grasp, what is a teraflop? Oh shit, that's a lot of compute, right? Like, it's switching at gigahertz speeds, right? And there's billions of transistors. It's like people lose sight of like how fantastic what we've made is when they kind of get in this like, oh, it could be simpler. Oh, it's not good. Blah 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 blah.
It's amazing. I'm gonna do a lightning round to finish up. What is artificial general intelligence to you? Like, what does it mean when someone says AGI?
It's what's advantageous to use in the conversation. That's what they're using the term for.
Right on.
It's better than humans in every way. I don't know.
Better than humans in every way. If you had to put a date on like when AGI would be achieved, when do you think AGI would be achieved?
Actually, that definition sucks. I think AGI in like 2028, but ASI, right? Artificial superintelligence, maybe like 2032 or something like that, right? Like, it's going to take a little bit longer.
Okay.
So ASI is where it's better than humans in every way, right? In terms of thinking.
Better than humans in every way. All right. And AGI being on par with humans in every way, something like that.
Just generally intelligent, right? Like, good, better than humans in some ways, right? Like, better at recognizing cats in photos for sure. Already happened, right? So it's AGI in that sense, right? It's generally intelligent in that sense. It's better at making poems or finding shit on the internet, but then it's way worse at other things, right? So I think there will be a continuum for AGI, and people can have whatever definition they want there.
Amazing. That's pretty much it for the show. I want to thank you, and I'm going to end the show now. Emergent Behavior is a part of the Turpentine Network. For our full newsletter, visit emergentbehavior.co. For more Turpentine podcasts and sponsorship inquiries, visit turpentine.co.